Hello and welcome to the CSE 110 workshop presented by Fulton Schools of Engineering Tutoring Center. Today's agenda is UML diagrams, then writing classes using those UML diagrams, and we'll also go over method overloading. Before that, I'm just going to pause here for a sec so that you could have access to the QR codes of our social media, the Tutoring Center's social media. Over here, you can get updates, regular updates about our workshops and the tutor schedules. All right, and I have this link in the chat for you guys. Please sign into the workshop before we begin. All right. I'm Aishwariya. I'm a computer systems engineering junior, and I joined the special programs team this fall. So today, like I said, we'll be learning how to write, we'll be practicing how to write classes from UML diagrams, and we'll also go over method overloading. Starting off with UML diagrams. So a UML diagram is typically used in Java to express what a class would look like, what the attributes and methods of that class would be. It's a nice, concise way of specifying a class. So you have three parts of the UML diagram. You have the class name, over here it's account. Then you have a section for attributes. That's where you put the variables you're going to declare for that class. We have int ID and double balance here. So the way you write it, you write the name of the variable, colon, the data type, and then the value it's going to be initialized with. Next, the next section has operations or instant methods. These are the methods that will be included in the class. We have this method up here, which has the same name as the class. That is your constructor. Remember, the constructor has the same name as the class. So this constructor is, it takes in two values, int and a double. Next, we have get ID. This takes in nothing, basically. So the input list for this method is not required. You can just call this method without giving it actual parameter list. And its return type is int. So you have the method name in the brackets. You will write your input data types. And after the colon, you will write the return type. So you will notice that we have negative signs over here and positive signs over here. So what do these signs mean? These are visibility modifiers. So the plus sign denotes public classes or variables. It can be accessed by any other class from anywhere else. So it's not just specific to that particular class. Private, on the other hand, denoted by the minus sign, can be accessed only within the same class. So as we saw before in this account class ID and balance, they're private variables, so they can be accessed only by methods of this class itself. However, these methods can be accessed from other classes, like the main. You could call these methods in the main because of the plus sign, because they're public methods. But you couldn't access these variables from main because they're private only to this class. Then we have protected variables or methods which are denoted by the hashtag sign or the pound sign. So these can be accessed by classes in the same package or child classes of that particular class. And if there's nothing, if there are no visibility modifiers, then the default, it goes to the default value, and that can be accessed by other classes in the same package. And we're gonna go over how to write classes using UML diagrams. So while writing classes, we follow an outline. No matter what the program you're asked to write, it's a good place. A good place to start is defining these four methods. So you'll have the constructor, which basically initializes the values which you have declared in your class. Like for the account class, we had int ID and int balance. So the constructor is where you would initialize them. And accessor is also known as the getter. Here is this method basically returns the value of the variables in that class. So you can access the variables of that class through an accessor. And a mutator, which is also called a setter in some cases. So a mutator, like its name, it lets you mutate or change the variables of that particular class. And the toString method, as you know, is used to print out the data related to an object of that class. And after that, once you specify this, you could go on making other methods as required by your program. So this is a basic outline of all these classes. So you have some class name. You have your variables initialized in them. Keep in mind they're private variables, like in the UML diagram. So I'm just following the notation of the UML diagram roughly. And then we start writing our methods. So these methods are public, we'll see over here, because of the plus sign. And this first method has the same name as the class. So it's the constructor. So we have our constructor first. Then we have our accessor. So accessors are usually when we name accessors or getters, we write get in front of the method name. So if you want to access the name, suppose, oh no, you want to access the ID of the account, so you would do get ID. Yeah, you would do get ID. And suppose you want to change the ID, or if the ID was somehow updated, you would set ID. So that would be your mutator. Then, okay, and also keep in mind over here that get would just return so in get ID, you're returning an ID, and that ID is of type int. So you would have public int get ID. You're returning something over here, and you have no input list because you don't need one. You just want to access the ID, so you don't have to give the method any input. But in the setter, you want to set the ID, so you want to set the ID to something new, so to a new ID, and that ID is of type int. So you would have int some number maybe for some ID. And then since you're not returning it, you're just gonna set the ID to the class, and you don't have to return anything to main. The return type is void. Then we have our toString method in the end, and if needed, you could specify other methods as well. Okay, moving on. So here's a class called student. You have your attributes up here, which are the variables to be declared in the class, and you have your operations or methods down here. So I'm gonna wait over here for some time to give you a chance to write the class for this UML diagram. So keep in mind, you already have everything specified over here. So this would be your constructor. Here are your accessors. This is your mutator. You have just one mutator in this class. Here's your toString, and you have two extra classes in this. So I just want to specify that add class has the input type int. What I mean from this is that the number of credits. So you want to add a 3 credit class. So you would have int 3 inside. And similarly, you want to drop a 3 credit class. So you would have 3 over here. So I'm going to wait for some time so you could get a chance to try this out yourself, and then we'll go over the answers. Okay, we're gonna go over the class now. So here's the full code of this this class. So the class's name is student, so we start with class student. We have two private variables. So we have private string name and private int student ID, phone number, and total credits. So the first method we had was the constructor. So we would name it public student. It has to have the same name as the class. And inside we had this input list. So we had, okay, my mistake over here. I forgot to mention the two more ints over here. So if you need to call this class, you need to have all four inputs over here because that's how you would initialize these values or create a class object. So the name, so this name over here, the variable declared in the class would get the new name. So in so assignment happens from the right to the left. So this new name over here comes from this. So when this class is called, the new name over here is this one, and it will be assigned to the name over here, which is your private variable. So over here, you can access this variable because this method is part of the student class, so it can access a private variable. So this name gets copied into that basically. So then ID gets copied into student ID, new phone number into phone number, and num credits into total credits. Then we have public, another public class, get name. So it's public because of the plus sign, and its return type is string and get name. So it doesn't need any inputs because you're basically just returning something to the user. You don't need inputs to return that name. So over here, we simply have to return the name. Then we have the getter or accessor for ID. So public, then data type, return type int, and the name get ID. Again, no input parameter list. And then we have simply return student ID. Next, we have the accessor for phone number. Similarly, it's public int get phone number, and it returns phone number inside. And we have accessor for total credits over here as well, written in the same way. Now, we have a mutator. So mutators are written as set, whatever the name of the method, a related name. So we have set phone number over here. So it doesn't have to return anything. So the return type is void. But if you're setting a current phone number, that means you're updating the current phone number with a new value. You need to input the value. So you have int new phone number in this input list. So this new phone number is going to be assigned to the phone number variable in this class. So this phone number is updated with the new phone number. Now we had two extra classes in this. We had the add and the drop class methods. So we'll do public void add class int credits. So void because we're not really returning anything. We're just adding a class, like I said. So you add a class of 3 credits, suppose. So now you have to update the total credits variable in this, the total credits variable in this class. So if you're adding a class, the total credits increase by that amount of credits, right? So you would do total credits plus equal credits, which basically means total credit equals to total credits plus 3. So if the number of credits you're adding is 3. So you're basically increasing total credits. Similarly, if you're dropping a class, so this is a mutator as well. I know we said set phone number over here, like mutators are usually written as set whatever, but that's usually when whatever you're setting is a variable in this, like directly changing the total credits. Over here we have two mutators. Mutator matlab mutator meaning it's modifying or updating total credits. So we have add class and we have drop class. So drop class would take that amount of credits like in the input list, and it would subtract that from the total credits. So you have public void because it's not returning anything, it's just modifying total credits and modifying total credits by this amount in the input list. Finally, we have the toString method. So public string toString. Over here, I'm returning the details of the student class. So I have the name, the student ID, the phone number, and total amount of credits. Okay, so now how would you call the student class method from the main? So in order to access anything in that, first you need to create an object of the student class, and then to access the methods of that class, you would have to use the dot operator. So you would create an object of the student class, and then to use the dot operator, you would do object dot, suppose, get ID. So I have a small try it yourself exercise for you over here. So for the student class we just created, I want you to create a new object in the main and then change the phone number. So to create a new object, you have to use the constructor, right? So the constructor had 4 inputs: the name, the ID, what was it again? The name, the ID, phone number, and num credits. So you got to fill those in when you're calling the student, when you're calling the student class or creating an object in the main. And then once you have done that, I want you to set the number to something else. So change the number. How would you call the correct method for this? And I want you to add a 3 credit class. And finally, print the details related to that object. So I'm just going to pause here for a minute, and then I'll go over it. All right. So first, to create an object of the student class, we do student1 equals new student. And since the constructor has four variables in its input list, and the order over here matters, remember. So we have name, then phone number, a name, ID, phone number, and then the total amount of credits. So in that order, you have to create that object. So for name, I have Barry Allen over here. I have student ID, some number. I have phone number, some number again. They are int, that's why. And total credits 16. Now I've created this object. So we have to call the method to change phone number, right? So this is the basic syntax for calling the methods. You have the object created dot method name, and in the brackets, actual parameters if needed. So I just have student1 dot get ID as an example. So you have no parameters over here because the get ID method didn't need any. So you could just call the get ID method like this, and it would return the ID, which is this number over here, to you, to the user. And now we have to change the phone number. So we will use the set phone number method. So we do student1 dot set number, and in the brackets, we're going to put the number we want to change it to. So this number over here will basically be replaced by this number. And then we want to add a 3 credit class. So we will do student1 dot add class, and number of credits is 3 inside. So the total credits was 16, and it will be updated by 3. So it'll become 19 credits. So when you print, when you do system.out.println student1, it would directly call the toString method, and you would have the name Barry Allen, student name Barry Allen, then the ID, this ID. Now the new phone number is what you will see. So you'll see this phone number, and total number of credits instead of 16 will be 19 because you added this 3 credit class over here. All right, so now we're going to move on to method overloading. So in Java, a method signature is part of the method declaration. So what is a method signature? It's a combination of the method name and the parameter list. So why are the method name and parameter list emphasized? It's emphasized because of overloading. And overloading is the ability to write the methods having the same name, but they accept different parameters. We're going to see an example in 1 or 2 slides. So this is a method. Suppose you have a method public static int sum, and it has 3 integer inputs. This is your parameter list. So the signature of this method, excuse me, the signature of this method would be the method name sum and the parameter list. And in the parameter list, you don't have to specify the variables, you just the data types. So sum, in the brackets, we have int, and this is your method signature. So for method overloading, here's an example. So remember, overloading is the ability to write methods with the same name, but different parameter lists. So over here, we have a class sum. In that class, we have this method public int sum, where we have 2 integer inputs, int a and int b, and this returns the sum of a plus b. Now we have another method which has the same exact name, so public int sum, but the parameter list is different. We have 3 inputs over here instead. So this method returns the sum of a, b, and c. And then we have another method. This is the return type of this method is double because the input values are AA and double B. So it has the same name as the other two methods, but it has a different parameter list. So this is an example of method overloading. So the method sum is overloaded with 3 different parameter lists. So how would you call these? How would you call them in main differently? So first we create an object. So we have sum s equals to new sum. I created an object s of the class sum. And then over here, I'm printing out sum dot sum. Okay, so I'm directly in the print statement, I have called the method of the sum class using the dot operator. So I'm printing sum dot sum 10 plus 20. So these are 2 integer values. So it's going to call the first method over here because the parameter list, the actual parameters over here, the actual parameters are the values you're putting in, matches the actual parameter list matches the formal parameter list over here. So it's going to call this particular method. And it's going to return a plus b, and it's going to be an int answer. Then in the second line, I'm calling the parameter list changes. So the actual parameter list now has 3 integers, and it matches this second method over here. So this is what's going to be called. And the third list over here, third line is calling the third method because the actual parameters over here are doubles. So we have double 1, double 2. So this is going to call the last method over here and return the answer from here. So this is an efficient way to reuse a method to, it's easier to have the same method in different parameter lists than to have 3 different methods which are named differently. Okay. So here's our workshop summary. This is all I had for you guys today. We went over UML diagrams and then writing classes using those UML diagrams. So whenever you want to write a class in general, it's good to have defined these 4 methods first. It's a good starting place. So we have the constructor, accessor, mutator, and toString, and then any other methods your program would require. Then we went over method signature, which is basically the method name and the parameter list. Parameter list only needs the data types. And then we went over method overloading. So overloading is basically the ability to write methods with the same name, but they could have different parameter lists. Okay, thank you for joining this workshop. Hope you enjoyed the workshop. Thank you for attending.